Capacitive sensing is becoming a popular technology used to replace older methods of electronic switching, proximity sensing, and liquid level detection. Capacitive sensors are solid state, contactless, and have a low production cost, giving them an advantage over traditional detection methods. There are different types of capacitive measurement used by OEMs: capacitive sense and capacitive touch. Both use the theory of capacitive coupling, which can detect anything that has a dielectric that is different from air. The capacitors used for sensing are not conventional in design, but will retain limited charge. Let's have a closer, more practical look at this. As we know, a capacitor stores energy on a conductive plate. This plate is generally wound into a spiral to minimise its size. Capacitance is the ratio of the charge in relation to its storage capacity. We measure this in farads. A touch sensor is a capacitor, and as such, it will still store a limited charge for a very short time. The capacitance of the sensor affects its ability to conduct current. We can best see this when measuring the difference in time for a reference sent to the capacitive sensor to be returned to the control module. Using an oscilloscope, we can see the oscillating reference pulled from 5 volts to 0, then back to 5 again. This reference voltage is connected to the capacitive sensor, in our case, some aluminium foil. Our resistor is connected in series with our foil to create an RC, or resistive capacitive circuit. We can now monitor the return from the sensor back to the control module by placing the second channel of the scope to the signal terminal. Because it takes time for the capacitive sensor to charge, there will be a time delay when observing the second channel. This can be seen here. The higher the capacitance of the sensor, the longer the charge time. Once the control module has established its base values, it can very simply detect a change in capacitance by the change in the charge time of the sensor. When touching our sensor, the charge time will change. If we hold the capacitive sensor for a longer period, the time difference between reference out voltage and the signal in voltage will also extend. Because the sensor uses capacitance, the foil can be covered in an insulating material, but still operate as designed. A slight modification of the RC circuit allows the characteristics of the sensor to change. By increasing the resistance, we can change the sensitivity of the element. This means we can now use the circuit for proximity detection. This is a very crude sensor and it's slow to react. An OEM type generally has a 5 volt reference, ground and a signal out. This is a much more reliable and resilient design. The capacitive element is built onto a circuit board along with a very simple integrated circuit. When the capacitance of the sensor is high, the signal output is also high. When the capacitance is low, the signal output is also low. We can see this on the meter or an oscilloscope. The beauty of this type of sensor is the signal is digital. It can be used by a control module to operate an output driver. The output from the module can be used to control door locks, lighting, and even multimedia functions. Capacitive sensing may even be used by a manufacturer to determine the specific level of a liquid. These sensors work in a similar fashion to a capacitive touch sensor. Current flows in this circuit to a set of electrodes, or the sensing element. They are electrically insulated from each other and have the capacity to store a charge on their surface. When the sensing element is submerged in a dielectric liquid, the electrode's ability to store energy, or its capacitance, also changes. This change is relative to the level of liquid surrounding the sensor electrodes. The control module is calibrated to register the difference between a low or high fluid level based on the capacitance of the sensor. Nearly all liquids used in automotive have dielectric properties, so the sensor can be used for detecting engine oil levels, brake fluid and coolant levels, or even washer bottle fluid levels. So, the next time you use a capacitive touch button, take a moment to appreciate the ingenuity behind the sensor technology. Thanks for watching.